Good afternoon, folks. How's everyone doing today? Oh, come on, you can do better than that. Thank you. I would be excited if I were you, and I am excited, because we're here to watch Marta and Anna from Materialize present about streaming with DBT, the Jaffle Shop. Don't stop. Really excited for this talk. All Q&A and chat conversation will take place in DBT Slack in the channel Coalesce Streaming with DBT. If you're not on DBT Slack, head to community.getdbt.com and join. I imagine by now you're probably in there. Quick note, we're about 30 seconds ahead of the virtual attendees, so let's keep from sharing too many spoilers in the chat if we can. And otherwise, I'll let y'all take it away. Marta, Anna.
Thank you. Okay, thanks for the introduction, Ben, and hi, everyone. So besides being part of the developer experience team at Materialize, me and Anna are also the maintainers of the DBT Materialize adapter, which is why we're really excited to be here and just like walk you through how, surprisingly or not, DBT is a really great fit also for the streaming world. So since we assume not everyone in the room would be familiar with streaming, we thought we'd take just the most well-known project in the DBT community as a base for this talk. So we'll use the Jaffle Shop to kind of like walk you through most of the concepts here. So just to keep it super simple, let's imagine like the most bare bones setup that you can have to run analytics on the Jaffle Shop in the batch world. Maybe you have a Postgres database that handles transactional data for customers, orders, and payments. You run a periodic batch job on this raw data into your favorite cloud data warehouse, where you use DBT to model and transform the data into something useful. And on the other end, you might have something like a BI tool, in this case, Metabase, that lets you extract business insights from this transformed data. Now, in this setup, our Postgres database is very much a static source of data, literally just a collection of state about your business that is just sitting there waiting to be queried. But in reality, what happens is that most of the data that is stored in there is actually continuously produced and is constantly evolving and changing over time. Folks buy Jaffles when they feel like eating a Jaffle, right? It's the logic that you use to query the data that doesn't change as frequently. And when you start looking at things from this perspective, you kind of start wondering, if our data is being continuously produced, then why are we looking at data from yesterday? And why are we settling for data that is only as fresh as our latest DBT run? And why do we have to trade dollars for speed? If we want to have fresher data, we just have to be at peace with running up our cloud data warehouse bill. So the question we're trying to answer in this talk today is, what would it take to make the Jaffle Shop run continuously? And how different does this actually have to be from what you're already doing for batch with your current stack? So the first hurdle is that most of us are afraid of streaming, which is fair. Most streaming systems were born in the now hopefully distant Hadoop era, when quote unquote big data convinced us that managing our own clusters was kind of cool. And historically, like, these tools have just burdened us with implementation details that we don't really need to know about, like state management, time handling, fault tolerance, reading academic papers instead of documentation to understand what's going on. When, for the most part, these details should just not be exposed to us as end users, at least for the 99% of us. So we're now accepting that to go mainstream, streaming needs to look and feel more like whatever we're doing for batch today. And batch basically just looks like SQL. So the real blocker here is the tools. So if we could, we wouldn't choose to show stale data in our dashboards or send our notifications hours after you made a purchase. We just had to settle because we've been given the wrong abstractions all along. And this is basically why we built Materialize. It brings together all the things we love about traditional databases, like just being plug and play into whatever stack you already use for analytics, just how accessible and complete SQL support is, and how you get, for example, really strong consistency guarantees out of the box. But then it also just hides away all the parts that go into making SQL go fast. So our goal is that if you have ever in your life used Postgres, which I will assume you have, you know how to talk to Materialize, and Materialize will also know how to talk to your stack. So from a bird eye view, what Materialize does is it allows you to just continually ingest data from things like OLTP databases like Postgres, or if you're already in a streaming architecture like message brokers like Kafka or Red Panda. And you just use SQL to interact with Materialize. You define some Materialized views over whatever data you're getting from your sources, which we'll talk a bit more about in a little bit. And then you just use that transformed data to power analytics and applications downstream with low latency. So even if you're not familiar with streaming, this doesn't sound too unfamiliar, right? Who in this room has never heard about Materialized views? Only Pedro. Sorry, we don't support pivot tables yet. So exactly because you've heard about Materialized views before, let's focus on what makes our support for Materialized views different to other databases that you might be using today and be frustrated with. So in general, Materialized views are really useful when you have to avoid rerunning queries that are very heavy, but that are very frequently asked again and again against your database. And you just basically use them to cache the results so that they can be served faster. And this also means because the results are cached that you might be serving stale data frequently to your end users. And the two main issues, other than stale data, is exactly that you need to compromise between how fresh you want your data to be and how much it costs to refresh that data. And also the limitations around how complex the SQL queries you can write are. The limitations for SQL-wise vary from database to database, but things like joins or complex aggregations are generally really poorly supported. In Materialize, though, these views are incrementally updated as new data arrives from your streaming sources, and they're still the exact same type of database object. They are still defined using the same exact standard SQL syntax, but the engine that is behind Materialize is just extremely efficient at doing just enough work to make sure that your results are always up to date, rather than recompute everything from scratch every time. And this means that when you read from an incrementally maintained Materialized view, which is also a mouthful, you will always get correct, up-to-date results when the actual engine is doing very little work. The downside is usually that this sounds too good to be true. A few weeks ago, someone literally asked us, so are you poorly documenting the limitations on purpose, or is this just magic? And the answer really is that there are no limitations. This is an example of a Materialized view that you can create in Materialize, and it will just automatically be maintained up to date as new data flows in. And you can see that there's a bunch of joins in here, aggregate functions, oops, CTEs, more joins. So as long as something is supported in standard SQL, we pretty much can gobble up anything in a Materialized view. And so it's magic in the sense that we are hiding the streaming engine, and it's actually built on top of like very powerful and very long researched academic work by Frank McSherry, which is one of our co-founders. But it's also the best kind of magic because you don't really need to understand any of this to use Materialize. All you need to understand is that if we have a materialized view that is keeping track of the revenue of our Jaffle shop, and someone buys a Jaffle, we don't recompute things from scratch, but we just calculate the new sum incrementally. So instead of adding up each sale again and again every time someone wants to know the revenue of our Jaffle shop, we simply add Ender's order amount, and then we get the total. And this is how incrementally updated Materialize views work, and they are the beating heart of Materialize. So now off to how this has anything to do with DBT. So although DBT was built with batch in mind, and probably everyone in this room is using DBT to handle their batch workloads, it turns out that as long as you point it to a SQL backend, what's running under the covers becomes an implementation detail and doesn't really matter. So we built an adapter, DBT Materialize, that you can pip install like you would install any other DBT adapter. And the difference is that you can now build and manage your streaming pipelines using the exact same workflow that you use for everything else in your stack. And very little actually changes when you want to use DBT for streaming. So one thing that stays definitely the same is how you define your transformations. You interact with Materialize using SQL, so you write your DBT models in SQL. You also get to use the same DBT commands that you're already using. So DBT run, DBT test, DBT docs, they all basically just work. And you'll see in a bit in the demo that these commands can actually be even more powerful when you are using them over streams. And because those same DBT commands work, you'll still get the same documentation, lineage features, which is actually great because building lineage for a typical streaming stack is a mess. And there are only a few things that change if you use DBT with Materialize. The first thing is that we had to implement some custom materializations, like the materialized view materialization, which are not supported in DBT for other databases. If you go into the DBT core repo, there's an issue that's been open for a few years now for materialized view support and generic materialized view support in other databases. And the one other thing is that, like I mentioned before, some comments are supercharged with the power of streaming, which Anna will show us next. And I'll pass it over to her so that she can show us how Materialize and DBT work together.
Thanks, Marta. Materialize sounds awesome, no? All right, so we chose to go with Jaffle Shop just to demo how you can take an already created DBT project built for batch and transform it into one purpose-built for streaming with just a couple of changes. So we went ahead and set up a Postgres database hosted in the cloud. It will act as our backend for our Jaffle Shop store. And we will set up Materialize to consume from that Postgres database. Importantly, we needed to set up Postgres with logical replication enabled. This allows Materialize to receive changes as it would if it were any other read replica you might set up. And then we'll just show you how we can surface some really great visualizations. First step, go grab your credentials. As Marta pointed out, we are Postgres compatible, so you can use any tool you would otherwise use to interact with the Postgres database. And then we'll update our profile.yaml file with the correct information for our cloud instance. Next thing to do, create a source. In Materialize, sources describe the external systems that we want to read data from. So in this case, we're reading from a Postgres connection. We've given our publication that we defined over in the Postgres database. And we've provided within the DBT adapter a special source materialization to allow you to inject your full SQL statement into this source.sql file. On the right-hand side, we're just defining DBT sources so that we have better lineage, and then we can select from the source table downstream in our staging views. If your internal data stack looks more event bus, less relational database, as Marta mentioned, we also have a Kafka source, which would be a better fit. The next thing we'll do, as you would in the other project, is model the data. We've chosen to go with views, which are just alias SQL statements here for our staging data. And as I showed before, you can directly select from your source. And then the cool bit is the materialized views. We are telling Materialize to create them to join over our data source, aggregate, and incrementally maintain the results as data streams into our source. So here's me just running dbt run with the Jaffle Shop. You can provide the materialization strategy either in the .sql file itself or for groups of models in your global project. One important thing to note here is we need to run dbt run once, only once, using Materialize, because we take care of the updating of your actual data. So you don't need an orchestrator to schedule your runs for you. As with any other project, documentation is important. So here we're just showing you that the green is our sources, then our staging models, which are just views, and then our materialized views over there at the end, updating incrementally. The last thing we'll do is test. So I can run dbt test during development, just as I would against any other backend, and understand the changes that I'm making to my SQL and how they'll affect the downstream models. But with Materialize, if you add this stores failure flag during a production run and run dbt test once, we'll create a materialized view for every test condition you've defined. So if your ETL pipeline is working really great, no problems, then those views shouldn't have rows in them. But if something upstream got mucked up with your database and a condition that was formerly true became false, you'll see a row in the direct table that or materialized view that you've defined, giving you information about what failed at exactly what time it failed. So here's an example of a visualization we made just using this Jaffle Shop data. As you can see, it's updating in real time. We can plug Materialize into our existing analytics stack because it's Postgres compatible. And the top view is we triggered an alert to happen. dbt ships with an accepted values test type. In this case, we added a payment type that our data engineers were not aware of, but our product engineers had already built. So 166, 7, 8 people are paying with a different version of a payment method than we as data engineering know about. So we'll need to go model that appropriately. And we know about it right when it happens, so we can get in the code as quickly as possible. Yeah, with that.
Cool. So that's about it. We hope that this gave you a glimpse into how streaming doesn't have to be hard. With the right tools, it can just mean still just writing SQL and putting together some dbt models. And with something like Materialize, you can literally not change anything in your analytics stack other than starting using Materialize and process changes as they happen. Still use SQL to transform your data, but have the database take care of keeping things up to date rather than worrying about incremental logic or, yeah. And we'll just keep things up to date for you, and with the bonus that you can do quality testing continuously, pipe these alerts in real time into your observability systems, and you can also rest assured that you're delivering nothing but fresh and consistent insights to your end users. Thank you.
All right, thank you, Marta and Anna. Great presentation. Be sure to go visit Materialize at booth 317. Q&A will be in the Slack channel if you have any other further questions. Otherwise, the next session will be adapting data at the speed of business in here starting at 4:45 Central. We'll see you there.